Hi everyone, this is lesson 6.3. Prior to lesson 6.3, you would have learned SOHCAHTOA and the trig ratios of a right triangle. So in this lesson, what we're going to do is use SOHCAHTOA, and we'll talk about that in a sec, SOHCAHTOA within context, and what I mean by that is in word problems. And we're going to be able to draw an accurate diagram from given information. And basically what we're doing is we are problem solving. So just a reminder, what do I mean by SOHCAHTOA? Well, I mean the primary trig ratios. So if this is my angle of consideration and this is my right angle, the side opposite my right angle is always my hypotenuse. The side opposite my angle of consideration is called opposite. And then the remaining side is called adjacent. It's also adjacent to the angle. And we said that sine, which is this part of the memorization device, it's opposite over hypotenuse. Okay, the ka part stands for cos. Cos theta is adjacent over hypotenuse. Remember, these are ratios of sides. And TOA is tan, always of an angle, and that's opposite over adjacent. So now that we've summarized that, let's just jump right into some examples. So in the first example, I actually provide the diagram for you, but I still describe it in words. A boy flies a kite 100 meters above the ground. When I see this, this is always going to be a vertical distance, okay? So if I say above the ground, it's the vertical distance above the ground. The angle the kite string makes with the ground is 55 degrees. How long is the kite string to 1 decimal place? So this is all labeled nicely for us. We can see we have a right angle. So what I'm going to do is circle 55 degrees. It is my angle of consideration, making this the opposite side, this the adjacent side. And of course, this is the hypotenuse. I can see that the information I know is 100 and the information I'm looking for is x. So that means I should use the sine ratio to connect opposite and hypotenuse. And now I just fill in the numbers. Sine 55 degrees is 100 over x. Okay, and now is a good time to tell you that throughout your calculations, you should use 4 decimal places, and then you round at the end, the very last line, which means it's advisable for us to not put sine 55 into our calculator until we really need to. So all I did here was cross multiply, and I'm going to say that x is 122.0775, and my final answer is the kite string is, and it says to 1 decimal place, 122.1 meters long. I'm going to put a box around my answer. All right. Example 2. The side adjacent to the 74-degree angle in a right triangle is 6 centimeters long. How long is the hypotenuse to the nearest tenth of a centimeter? So what I'm going to do is I'm just going to draw, I don't want to call it a random angle, a right triangle, but a right triangle, and one that has one angle bigger than the other angles. So maybe I'll actually bring this down a bit. So I can see that the way I've drawn this triangle, this one's probably makes more sense that that's my 74-degree angle. If I wanted to do some math, like this one's 16, so we can see that it's much smaller than 74. Now, this is always the hypotenuse across from the right angle. So when I'm talking here about the side adjacent to the 74-degree angle, I'm talking about this one. This would be the opposite side, if that's my angle of consideration. So this information is telling me that my adjacent side is 6 centimeters, and x in this case is the hypotenuse. So again, I have to consider, well, this is what I know, this is what I'm looking for, so I need a relationship between the adjacent and a hypotenuse. The opposite side doesn't really play into this at all, so I'm going to use cos theta, which is adjacent over hypotenuse. Cos 74 degrees is 6 over x. X equals 6 over cos 74. X is 21.7677. My answer to the nearest tenth. Okay, the hypotenuse is 21.8 centimeters long. All right. Example 3. Triangle ABC is an isosceles triangle with two side lengths equal to 10 centimeters and two angles equal to 40 degrees. So we have to know a little bit about isosceles triangles here. Isosceles triangles have two of the same sides. In this case, they're both 10 centimeters. And it says two angles equal to 40. Well, it's not going to be these two, right? It's not going to be those two. If this is truly isosceles, what that means is that these two angles need to be the same, okay, because the opposite sides are the same length. So we have to understand that these are the two angles that are 40 degrees. Now it asks us to determine the height of the triangle, and we know that the height of a triangle is the same as altitude. Okay, it's the 90-degree line from a vertex to the opposite side. Okay, so in this case, what we can do is figure out h by calling this h and saying, if this is my angle of consideration, okay, I know that h is my opposite side, and 10 centimeters is my hypotenuse of this triangle. I'm just going to separate the triangle out so it's a bit easier to see. So h is my opposite, my hypotenuse, and h in this instance stands for height, not hypotenuse. So I'm going to use sine. Sine 40 degrees is opposite over hypotenuse. So h is 10 sine 40 degrees. Again, I'm not going to type in sine 40 until I have to, right at the end. And 10 sine 40 is 6.4279. I'm going to look at how many decimal places. Well, it doesn't say. So in this case, I'm going to round to one decimal place. The hypotenuse, sorry, the height is 6.4 centimeters. All right. Let's do both of these questions to one decimal place. Okay. So determine the perimeter and area of the triangle. Okay, so if I want to know the perimeter of this triangle, actually, I'm just going to do this. Okay, so now I actually know that this height here is 6.4 centimeters. So what I actually need to know for the perimeter is this length. And to find that length, essentially, I'm going to duplicate this again. And I can erase this. I know this is 6.4 centimeters. And now I want to find this distance. We can call this y. And I can use Pythagorean theorem. So I know that 10 squared equals 6.4 squared plus, actually, let's use trig. Why not? Okay, so in this case, if this is my angle of consideration, I know opposite and hypotenuse, And the thing I'm trying to find is the adjacent side. So what I can do is I can use tan, or let's use cos. We have cos 40 degrees is adjacent over hypotenuse. And I can say that y is 10 cos 40 degrees, and y is 7.6604. Now, how does that help us? Well, it gives us half of the base of this larger triangle. So if I know that y is 7.6604, therefore, from here, I know that the base is 2 times that, and that's going to be 15.3210. So this distance here is 15.3210. This is the base of our triangle. Okay, so I know that perimeter happens when I add up all of the sides. Let's do this to 1 decimal place. So the perimeter is 35.3 centimeters. And I know that the area of a triangle always, I'm just going to put it in centimeters. Okay, and the area is base times height divided by 2. And we have area here, space. So we've got 15.3210 times 6.4279 divided by 2 divided by 2. And when I round that, well, it's 48.96. So when I round that to 1 decimal place, it's actually 49.0 centimeters squared. All right. Next, the area of a right triangle is 64 meters squared. One angle is 26.5651 degrees. What are the dimensions of the base and height? Now, this one's a little trickier than it looks. Let's just start by drawing a triangle. Oops. Okay. So I'm drawing it like this with one angle smaller than the other. This one's 26.5651 degrees. And I know the area of any triangle is base times height divided by 2. So in this case, the area of my triangle is 64. It's asking me what are the dimensions of the base and the height. So what I'm going to do is label my triangle, base and height, and I'm actually going to come up with a system of equations. So I have 2 unknowns here, b and h, meaning I need 2 equations in my system to be able to solve it. Now, I already have one right in front of me. The first one is 64 equals base times height over 2. That's my area equation. Now my second equation is going to be a trig equation. And if I consider 26.5651 to be my angle of consideration, h is opposite and b is adjacent. So what I'm going to do is use the tan ratio as my second equation. And obviously, I'm going to keep in all of those decimal points because they were given to me, so they must be important. Opposite over adjacent, which is b. All right, so what I'm going to do, oh, it's weird. What I'm going to do is I'm going to take equation number 1, and I'm going to clear the fraction by multiplying both sides by 2. So I get 128 equals base times height. And then what I'm going to do is use substitution. So I'm actually going to replace my h. I'm going to isolate h in this equation. So 128 over b equals h. And I'm going to sub this into equation 2. Okay, and let's do it over here. So in equation 2, I have tan 26.5651. And instead of h, I'm going to write 128 over b over b. Now, if you remember, when I have a fraction divided by a whole number, one of the tricks I can do is I can write the whole number as a fraction and remind myself that the division rule of fractions is if I have, I'll do it in purple, if I have a over b divided by c over d, that's the same as a over b times d over c. So what I'm going to do is write this as tan 26.5651 equals 128 over b times 1 over b, and that just simplifies to 128 over b squared. Okay, now I'm just going to use cross multiplication to isolate b. 5, 6, 5, 1. And when I type this in, I'm going to use 4 decimal places. I get 255.9995. And then I'm going to take the square root of both sides. Now, last unit we talked a lot about using the plus minus here, but I don't have to here because I'm talking about a side. So I know that my answer has to be the positive version of the answer. And look at that, I have like basically 16. So if I have 0 for 4 decimal places, I can say that b is 16. Okay, so now what I can do is I can take this and sub it into equation 1 to figure out what h is. So I know that h is 128 divided by b. H is 128 over 16. H is 8. And if I wanted to, I could double check to make sure that my area works, right? What is the area of this? I know that area is base times height over 2. And in this case, I'm going to get 16 times 8 divided by 2. And that is indeed 64. So I know I've done it right. All right, last page here. So we have to discuss the wording of this next question. It says a ladder leans against a wall at a 65 angle to the ground. The distance between the foot of the ladder and the wall is 1.8 meters less than the length of the ladder. So in the past, some guys have a hard time figuring out what this means. What is the foot? Well, if you think about your ladder as having like a body, so think of the head as the top of the ladder and the foot as the bottom of the ladder. So the bottom of the ladder would be like the foot of a ladder. So if I'm going to make this look like somewhat real, okay, so let's say this is my wall here, and brown, sure. This is my ladder. I'll try to draw it like a, no, it's not what I mean. Okay, so maybe something like this. So here's your ladder. This thing here, this is what I'm referring to as the foot. The foot is the bottom of the ladder. So after this question, anytime I talk about the foot, we should have a full understanding of what that is. This is the foot of the ladder. Okay. And, oopsie, wow. Okay, and no funny like angles or anything. If it's a wall and a floor, always 90 degrees. So what we're going to do is we need to figure out how far up the wall the ladder reaches. Okay, so essentially what I want to know is this distance here, which I'm going to call h for height. Okay, and it says the ladder leans against the wall at a 65 degree angle to the ground. So this angle here is 65 degrees. So I'm just going to draw a simplified version of this triangle. Okay, so here's H, here's 65 degrees, and then we have to read the rest of the words. It says the distance between the foot of the ladder and the wall is 1.8 meters less than the length of the ladder. So if I let x represent the length of the ladder, then this distance here is x subtract 1.8. And we could somehow integrate Pythagorean theorem here, but we have two unknowns. So what we actually want to do is we want to solve for x first by creating an equation that just involves x. So what I'm going to do first is recognize that in this triangle, this is my hypotenuse, and if 65 is my angle of consideration, then I know that h is my opposite side, and x minus 1.8 is my adjacent side. So the first thing I'm going to do is solve for x, and the reason I'm doing that is because I can see that I can set up an equation using cos. So if I take cos 65 degrees and I write down adjacent over hypotenuse, I'm only involving x in my answer, right? So what I can do now is actually cross multiply, so I'll end up getting x times cos 65 degrees. Okay, and this is a little tricky because what I want to do is isolate for x. So I have to put all my x values on one side. So what I'm going to do, and at the same time what I'm going to do is actually I'll evaluate cos 65 because it might be a little bit easier to understand. And then at the same time I'm going to bring this x to the other side. Subtract x equals negative 1.8. Do not forget this negative, please. Okay? So now what I'm going to do is recognize that this is the same as 0.4226x subtract 1x. So in my calculator, I'm going to do 0.4226 subtract 1, and I'm going to get negative 0.5774x equals negative 1.8. And then I isolate for x by dividing both sides by negative 0.5774, and I get that x is 3.1174. Rounded to one decimal place, I know that x is 3.1. So what that means is that if I go back to my picture, it means that my ladder is 3.1. Well, actually, let's draw it one more time. Maybe I'll draw it in a different color. It means that my ladder is 3.1 meters. I still don't know what h is, but 3.1 subtract 1.8 is 1.3 meters. So my ladder is 1.3 meters away from the wall. And if it's really what I'm looking for is h, so at this point I can use Pythagorean theorem. So h squared plus 1.3 squared is 3.1 squared. I'm going to get h squared is 7.92. I take the square root of both sides, but remember in this case I only need the positive number because it's a side. The ladder reaches, we're going to round to one decimal place, 2.8 meters up the wall. In general, if I forget to tell you how many decimal places to include in your answer, you can just look at the question and recognize, hey, I was given one decimal place, so I'm going to give my answer in one decimal place. Okay, last question. So we have to talk about this sentence, angle of elevation. What is that? Okay, the angle of sunlight is the angle of elevation from the tip of the shadow to the top of the object casting it. If the angle of sunlight of 48 degrees creates a shadow which is 6 meters longer than the building casting it, how tall is the building? You must include a diagram. So this is what it means. Let's say this is my ground and I have a building. Okay, so here's the sun. Okay, and I'm going to pretend that that's the sun rays. And essentially, I have a shadow being cast by the building, okay, from blocking the sunlight, so the shadow's on the ground, okay? So one more time, the angle of sunlight is the angle of elevation from the tip of the shadow, so this is the tip of the shadow, to the top of the object casting it. So essentially, what we're saying is the angle of elevation is this one right here. So essentially, if there was a person standing at this place, how far would their chin have to move up to see the sun? We're going to talk more about angle of elevation next time. So this is the tip of the shadow, or top of the shadow, I guess. Okay, and now that we've labeled this, I know that this is also going to be 40 degrees. It doesn't really play into it, but it's, good to know. The question is asking us, how tall is the building? So I'm going to call the building X. And it says here that it creates a shadow which is 6 meters longer than the building casting it. So what that means is that the shadow is X plus 6 meters long. So this is going to require a tan ratio. So we have tan 40 is opposite over adjacent. Then what I'm going to do is cross multiply, but recall that when I have division like this, there are actually implied brackets around X plus 6. Okay, so it's going to be X plus 6 times tan 40 degrees equals X. And then I'm going to evaluate tan 40 degrees at 0.8391. And I prefer to write that number in front as a coefficient because it looks better and it makes more sense. And now I'm going to use the distributive property. I get 0.8391x plus 5.0346 equals x. And now I have to isolate x. So I'm going to collect like terms by bringing 0.8391x on this side. And just a reminder that there's a 1 here, so all I do in my calculator is I type in 1 and then I subtract 8.8391 to get 0.1609x. I divide both sides by 0.1609 and I get x is 31.2902. And I'm going to round that. The building is 31.3 meters tall. All right. So we're going to end there. And next time we're going to talk a bit more about angle of elevation and angle of depression. But this is what you need to know to get the homework done for this lesson. Okay, good luck, guys.